India has taken a giant step towards becoming a global superpower. A proud moment for the entire countrymen, amidst the current border tensions with China. Yesterday, India has successfully tested an indigenously developed hypersonic technology demonstrator vehicle, HSTDV, powered by a scramjet engine, which will serve as the building block for next-generation hypersonic cruise missiles. The test of Hypersonic Test Demonstrator Vehicle, developed by Defense Research and Development Organization, DRDO, was conducted using the Agni missile booster and lasted for 5 minutes. The test of the HSTDV, designed to cruise at Mach 6 speed with the scramjet engine, was conducted from the Doctor Abdul Kalam Island, off the Odisha coast at 11:03 am. HSTDV met all the laid-down technical parameters. India now joins an elite group of US, Russia and China that are already possessing the technology. With the successful HSTDV flight test, using the indigenously developed scramjet propulsion system, all critical technologies have now been established to progress to the next phase. This indigenous technology will pave the way towards development of missiles traveling at 6 times the speed of sound, Mach 6. The HSTDV has a range of uses, including missiles of the future, and energy-efficient, low-cost and reusable satellite launch vehicles. The parameters of launch and cruise vehicle, including scramjet engine, was monitored by multiple tracking radars, electro-optical systems and telemetry stations. The scramjet engine worked at high dynamic pressure and at very high temperature. A ship was also deployed in the Bay of Bengal to monitor the performance during the cruise phase of hypersonic vehicle. All the performance parameters have indicated a resounding success of the mission. With this successful demonstration, many critical technologies such as aerodynamic configuration for hypersonic maneuvers, use of scramjet propulsion for ignition and sustained combustion at hypersonic flow, thermostructural characterization of high-temperature materials, separation mechanism at hypersonic velocities etc. were proven. The hypersonic cruise vehicle was launched using the proven solid rocket motor, the Agni missile booster, which took it to an altitude of 30 kilometers, where the aerodynamic heat shields were separated at hypersonic Mach number. The cruise vehicle separated from the launch vehicle and the air intake opened as planned. The hypersonic combustion sustained and the cruise vehicle continued on its desired flight path at a velocity of 6 times the speed of sound, nearly 2 km per second for more than 20 seconds. The critical events like fuel injection and auto-ignition of scramjet demonstrated technological maturity. The scramjet engine performed in a textbook manner. The vehicle performed successfully on all the predetermined parameters, including the ability to handle combustion temperatures of over 2500 degrees Celsius as well as air speed. Considering the strategic nature of air-breathing technology, which has the potential to bring a significant shift in the launch vehicle design, worldwide efforts are on to develop the technology for air-breathing engines. Ramjet, scramjet and dual-mode ramjet, DMRJ, are the 3 concepts of air-breathing engines which are being developed by various space agencies. An important development in Indian Space Research Organization's Air-Breathing Propulsion Project, ABPP, occurred on August 28, 2016, which was the successful flight testing of its scramjet. This successful test will add significantly to the capacity of DRDO to develop a hypersonic missile with scramjet engine in next 5 years, which will have the capacity to travel at more than 2 km per second.